You are now unmuted.
Hello everyone, welcome back to day 2 of a 2-week engineering conclave, Rethinking Engineering Futures. We have an exciting evening ahead with 3 insightful keynote sessions covering topics from cognitive system modeling to next-gen RFID antennas and the impact of women engineers in shaping future technology. We are pleased to welcome Dr. Ali Turab, Associate Professor at the School of Software, Northwestern Polytechnical University, China. Dr. Turab previously worked as a research associate at the Center of Excellence for AI and Data Science, UMPSA, Malaysia. His research combines mathematical modeling, artificial intelligence, and behavioral sciences with a current focus on cognitive modeling and hybrid neutral stochastic systems. He is deeply engaged in interdisciplinary research and academic mentorship in computational modeling and intelligent behavior. His keynote today, Hybrid Computational Approaches for Behavioral and Cognitive System Modeling, will explore how we can computationally represent and understand complex cognitive and behavioral phenomena. Let's warmly welcome Dr. Ali Turab. So, over to you.
You are now muted. You are now unmuted. You are currently the only person in this conference. You are now muted. You are now unmuted. You are now muted.
Hello and good afternoon. So can you hear me? Let me
You are now
fix it.
unmuted.
Okay.
You
I
are now
think
muted.
now my screen is visible, right?
You are now unmuted.
Okay.
You are
Okay.
now muted.
So good afternoon, everyone. So welcome to the 2-week engineering conclave organized by Stanley Engineering College. My name is Ali Trab. I'm working as an associate professor at the School of Software, Northwestern Polytechnical University, China. So the title of my talk is Hybrid Computational Approaches for Behavioral and Cognitive System Modeling. I would like to thank the organizing committee for their kind invitation. So let's start. These are the table of contents. I have divided my talk into 4 parts. The first part of the talk is related with the professional information, like what I'm doing now, some key research papers. Then we will move to the motivation, which is related with the analytical modeling and solution by using some techniques from functional analysis. And then we will connect our research problem with machine learning and AI. And in the end, I will try to propose some open problems for those who are interested in this kind of research. So let's start with the first thing, which is about professional information. So as I told you, I'm working at Northwestern Polytechnical University, China. If I talk about my research background, so I'm interested in modeling of complex problems, for example, related with the chemical graph theory, infectious diseases, cybersecurity and attacks, human and animal behavior. For example, when we find an interesting research problem, we try to model it by using some mathematical techniques. When the problem is in math, then we try to find the solution or of the proposed problem. And from the last 2 or 3 years, what we are doing, we are working on connecting problem with machine learning or AI, because some problems have the data set, so it's easy to make a connection. So this is my research team, which I want to introduce here in my talk. There, we are working on our common research problem from last 3 years. Professor Andres Montoyo and Professor Jose Antonio from University of Alicante in Spain, Professor Butipul Sintanawarat from Thailand, Professor Nur Hayati Rosali from UMP, Malaysia, and Professor Farhanullah from Prince Mohammed bin Fahd University, Saudi Arabia. These are my master degree students at NPU who are working with me on some topics related with cybersecurity and attacks. So the first problem which we are working now is related with the Nash equilibrium and its application in cybersecurity and attacks. As we know that in cybersecurity is one of the emerging fields, and in which we discuss different type of attacks. We are trying to model the problem with the help of some techniques and try to find the Nash equilibrium of that problem. Of course, we also use some machine learning and AI techniques to discuss such type of problems as well. This is our published paper, which published last year related with this problem, in which we discuss enhanced network intrusion detection system for Internet of Things using a multimodal big data representation with transfer learning and game theory. Specifically in game theory, we use the idea of Nash equilibrium. The second problem, which is related with applied behavioral analysis and learning theory, in which we observe the behavior of animals and humans in certain circumstances. For example, behavior of a rat in a team-based setup, which is a famous problem in biology. So if we talk about this, so this is our paper published last year related with the rumor spreading with the attitude of adjusting a mechanism. As we know that on social media there are different type of rumors, and we discuss the impact of those rumors by using the mathematical modeling of the problem and trying to find the solution of that, the proposed model. The second problem related with the behavior analysis is this paper, integral differential equation for modeling avoidance learning behavior, in which a rat is placed in a box, in which one side is has a shock side and another one is the without shock side, and we observe the behavior of a rat by using integral differential equation. This is the main paper. Our talk is actually dependent on this paper, in which the title is Computational Modeling of Animal Behavior in T-Mazes, Insights from Machine Learning, which published last year in Ecological Informatics journal. So in which we observe the behavior of a rat in a T-maze setup. So this is the end of the first part, in which I discuss what I am doing now with my students or with my research team. So let's move to the main problem, which is related with hybrid machine learning models for animal behavior analysis. So we'll start with the motivation. Actually, in this section, I will give you a short introduction of the technique which is commonly used in such type of problems, and the technique is the fixed point theory, actually. So if we talk about the fixed point theory, specifically the word fixed point, so we can say that a point which remains unchanged is called a fixed point. If you see this mapping tx equal to x, t is an operator and x is a variable. You are giving x, we are giving x to the operator t work on it, and we are getting back the same number. So in that case, it is called a fixed point of x is called the fixed point of operator t actually. And even we can observe such type of thing by using or by drawing the graph of the function. Assume the graph of this function which appears in the green line actually. Okay, and if we draw the graph of y equal to x line, and if y equal to x line, cut the graph of the function at any point, then that point is called actually the fixed point of that problem. If you see closely here, the graph of the function is f of x equal to 3.4x into 1 minus x. And if you see this line, cut the graph at 2 points. For example, the easy here and here. So this point is 0, and if you replace 0 here in this function, which is maybe a little bit, the font is small, but if you replace it here, f of 0, then the right hand side becomes 0. So in that case, 0 is a fixed point of that function. So there are different methods to find the fixed point, and in that case, actually the fixed point means that the solution of that problem. Okay, so this fixed point, finding the fixed point is our solution, is our actually the main task in some models. So we can find fixed point by using different method. Actually, this theory evolve in different spaces. We talk about spaces actually here. For example, metric spaces, topological metric spaces, discrete metric spaces. If we specifically fix the space, assume the metric space, okay? It means the metric distance, okay? Then in that space, the famous theorem is for finding the fixed point is the Banach fixed point theorem, which is also known as contraction mapping principle, okay, which is a work of Professor Stephen Banach. And this theorem is very simple actually. It says that if our mapping, it means that the operator mapping, if we have a complete metric space, it means that our space has some specific structure, which is called the completeness structure. And our mapping satisfy some condition, which we call contraction condition. Then we actually the contraction condition is explained here. Like in a metric space, a mapping Tx to x is called a Banach contraction mapping or a contraction mapping. If there is a constant k, which is less than 1, such that the distance, this is a distance function, between tx and ty is less or equal to k times distance between x and y, and this k is actually less than 1. If this property hold for a mapping in a complete metric space, then we get a unique fixed point. Unique fixed point means, for example, here you see that there are 2 fixed points. One is here, because this red line cut the graph of the function here and here. So it means that this mapping has 2 fixed points. Unique fixed point means that there is only 1 fixed point, and fixed point means that the solution of that problem, okay? So Banach fixed point theorem, what it says that in a complete metric space, if our mapping satisfies some condition, then we'll get a unique solution, unique fixed point of that problem. Actually, that is the technique which we use in our model for finding the existence of solution. Okay, if we talk about the complete statement of the Banach fixed point theorem, not like this, like a complete statement, you can see let xd be a complete metric space. As I said, the space should be complete, and then the self-mapping satisfies some condition, which is called the contraction condition, which is like this. Then we get a unique fixed point. Then there is an extension of this theorem that if we pick any point which is x0 from the set, and we construct an iteration process which is defined like this. Actually, this iteration process is called the Picard iteration process. Then the iteration will converge to the fixed point. It means that converge to the solution of that problem. This is the statement of a Banach fixed point theorem. The interesting thing for this theorem is, until now, it has more than 7,000 citations. of just this Banach fixed point theorem. So it means that its applications are very huge. We can easily apply this theorem in finding the solution of different problems, or we can extend this theorem to some generalized concepts. Okay, so one of the key thing in which a lot of researcher work is they change the space. The easiest thing is to change the space. It means that the Banach use the metric space. They use the space, they change the space and try to prove the same thing in generalized spaces. For example, in B metric space, in partial metric space, or in M metric space, there are different spaces. Okay. Another extension of this theorem is possible in terms of the mapping. This is a single valued mapping, but there is another kind of mapping which is called the multi-valued mapping. So a lot of researchers try to extend this theorem or prove it in terms of multi-valued mappings. And the famous theorem in that case is the Nettler fixed point theorem. Another thing, which if you out of 7,000 citation, around 6,000 citation is focused on this contraction condition. A lot of people try to change this contraction condition and make a new result. For example, sometimes they will add something here, sometimes they will add something here or subtract something here and try to make a generalized contraction. The easiest thing is, if you see here, k is a constant actually here, which is actually in this from this interval. You can assume or you can replace this k with some function phi of x. Okay, and then it is called the weak contraction in that case. Okay. Another thing is the Picard iteration, which we constructed here. Actually, the Picard iteration has a slow convergence rate, but normally we need faster convergence. Okay, so in that case, we can replace this this iteration process with different iteration processes. For example, Mann iteration, Ishikawa, or Krasnosalsky iteration, and many more. Okay. So all these are extensions in terms of theorem statement. But another field is still we didn't discuss about it, and that area is the application of the same theorem in different fields. If we just talk about mathematics, this theorem has a lot of application in ordinary differential equation, fractional differential equations, matrix equation, and in many research problems, even in case of real world problems. For example, in predator prey model, cell growth problems, scattering problems, graph theory, and many other. So this is the end of the second section, in which we discuss the technique which we will use on our model, and the technique name is the Banach fixed point theorem, and it states that if we have a complete metric space and our mappings satisfy some condition which is called the contraction condition, then we will get a unique fixed point. That is the very straightforward. So now let's talk about our model. So we will start with this paper. It published in 1953, which is a traumatic avoidance learning in normal dogs. It is a work of Professor Solomon and Professor Wen, in which they observed the behavior of a dog in this shuttle box operators. It means that dog need to jump from one side to another side. But you understand, or you like in psychology, if you learn the psychology of dog or animals, we cannot force them to do one task. Okay, so assume dog didn't jump from one side to another side. So what they did, they replaced the floor of this shuttle box and by metal rods and connected with some electricity. And it means that if dog didn't jump from one side to another side, then they give the shock to the dog, and due to the fear of the shock, dog jumped from one side to another side. Now assume if you repeat this experiment with the same dog again and again, again and again, after few tries, dog will learn that if dog didn't jump from one side to another side, dog need to bear the shock. And due to the fear of the shock, dog started jumping from one side to another side. And that is called the learning behavior of the dog. And this is the data which we got from this paper. If you see, we have the trials N, It means the number of trials from 0 to 19. It means that 20 trials. And this dog means the dog numbers. And if you see, they repeat the same experiment uh, with different dogs. And assume you can see on the data there is a capital S and then there is an empty thing. Capital S means shock, and it means that on this trial, trial 0, dog number 13 didn't jump from one side to another side, and they give the shock to the dog, and because of the shock, dog jumped from one side to another side. That's why they mark it capital S here. But there are empty spaces here. It means that dog jump at trial number 2, dog number 13 jump from one side to another side without the shock. And if you see after few trials, all dogs learn that if they not jump from one side to another side, they need to bear the shock. So these are the learning behavior of that dog. If you see here, dog number 13, the dog learned after trial 5 that dog need to bear the shock, and that's why you cannot see any capital S after that. So this is the first paper in which we discuss the learning behavior actually of dogs. The same thing or same situation appears in terms of human. This is the poker game machine in which the players need to insert the poker coin, and they need to and then there will be a buzzer here, and they need to press one of the keys, A1 or A2. So in that case, the players has two choices. They can press button A1 or button A2. If you see here, dog has two choices: jump or not jump, or jump with shock or jump without shock. So there are two choices here. Here also, players has two choices. The main experiment is this one, in which we discuss two choice behavior of paradise fish, in which fish is placed in a fish tank, which looks like a tea maze, in which fish has two choices to swim. Fish can move towards side A or towards side B. You can see that that's why it's called two choice behavior. So if I explain it in more detail, actually, what we did before, we observed this behavior and model it with the help of some techniques and use the fixed point method to discuss the analytical solution of this problem. And we published this paper in Journal of Fixed Point Theory in 2019. I will explain what it means. Actually, before that, as I told you that there are two choices for fish, and there is a food also. So, because we need to control the behavior of a fish by using something, it's like a reward, okay, in that case. So assume the food is placed on side A and fish move towards side A, fish will get the food. But if fish move towards side B, fish will not get the food because the food is placed on side A. But the divider which divides side A and side B is, if the divider is transparent, then there is a chance if fish move towards side B while coming back from this transparent divider, there is a minor chance, but there is a chance that fish can easily see, or even fish can understand that where the food is placed, and fish will start moving towards side A in the following trials. But what we did, we replaced this divider, the transparent divider, with the opaque one. It means that fish cannot see where the food is placed, and it means that fish need to find the food by its own experience. That is called the learning behavior of the problem. So if we use this idea of a peak divider on trial 1, if fish move towards side A and the food is on side A, fish will get the food. It means that the reward. And maybe with the same fish on the next trial, fish move towards side B, fish will not get the food. If we repeat this experiment with the same fish again and again, after a few trials, fish will learn that where the food is placed, and after that, fish will start moving towards that side, and that is called the learning behavior of that of the fish, and mathematically we called it the solution of the mathematical solution of the problem. So if we try to model this problem with the help of some mathematical techniques, you can see there are two events. Okay, it means that fish move towards side A or side B, or fish will get the food or not food. Okay, get the reward or no reward. Okay, and we model this problem by using the functional equation. You can see x and 1 minus x are the probability of getting the food or not food, or choosing the right choice. And we use the transition operators, okay, and we call it the closed interval 0, 1 as a state space. By using this functional equation, we can easily model such type of behavior. Actually, this learning behavior, the idea of learning behavior is not new, it is quite old. And we can easily extend it to different kind of animals. Specifically, it helps in animal training. And the famous experiment is like the Timmy's experiment, as I discussed it before in rats. So we already discussed the model. Now let's see how we can use our technique. Our technique is the fixed point theory, like the Banach fixed point theorem. We state that we need a complete metric space, and our mapping, the self-mapping, satisfies some condition, then we'll get a unique fixed point. If you see here, we have a closed interval 0, 1, and we use this kind of the finite norm, then we'll get a unique fixed point. All these are related with the functional equation thing, so I will not discuss in detail, but you can believe that the whole thing, this slide, means that the space is complete if we use this closed interval 0, 1 with the finite norm. So the first theorem say that we need to define an operator, which is the operator A, and we need to check that this functional equation, our proposed functional equation, satisfies some condition in that space. So if our operator is a contraction mapping, the Banach contraction mapping, then it means that the operator satisfies this kind of condition with k less than 1. So because we need to make k less than 1, so therefore we fix some condition here. Okay, so assume this theorem is like true, then according to the Banach fixed point theorem, in a complete metric space with a contraction mapping, then we'll get a unique fixed point. And another thing is, if we construct a Picard iteration, then the iteration will converge to the unique fixed point, or the solution of that problem. That is the analytical solution of that of our proposed problem. So now let's move to the machine learning method. So we have a data set which consists of videos in which we have video of rats, and even here we have zebrafish. For example, we have the video data set in which we can see the left and right movement of a fish or a rat, and then because the data is not like in balanced form, so we use different type of techniques to make it in the balanced form. Then we use the machine learning techniques to get to check the accuracy, precision, F1, and recall thing. So here we are using, or we are comparing the movement of two animals, different animals, zebrafish and the rat, in the same environment. So the scenario 1 means that the food is on the left side, and the rat moved toward that side. Okay, you can see the rat is moving toward that side. It is called the reward side. I already explained. In scenario 2, it means that the food is on the left side, but the animal moved toward the opposite side. It means that non-reward side. So it means no reward. So there are two scenarios in the video. Okay, reward side or no reward side. So the first thing is the comparison in terms of motion trajectories. If you see, this is the zebrafish movement, and this is the rat movement. You can see the zebrafish movement is quite zigzag as compared to the rat, because it's quite linear here. Okay, and this is the one difference. And if we want to use the machine learning, I told you that we can use different type of techniques to make it in the balanced form. And we divide our data in terms of testing and training. And we use CNN and LSTM, the hybrid model, and CNN GRU to predict their movement. And we got such type of results for model accuracy and model loss. And for this formulas, we can easily compare or compute their accuracy. For CNN and LSTM, we got 82.24% accuracy, and for CNN GRU, we got 80.52% accuracy. So that's it for the thing. But let's see for the last section, which is about the open problems. So we started with the motivation, and then some modeling results, and then we apply machine learning results, and after that we discuss some open problems. If you see, we started for this one in which a fish is placed in a fish tank and a fish has two choices. We can extend this kind of model to other animals. For example, in this cases, which is called the predator-prey relationship, in which a predator has two choices of prey. Okay, so we can extend this kind of model to other problems, even in terms of humans as well, because in terms of human, we always have more than one or two choices. Actually, more than one choice. We every time we have. So the first extension can be, we can extend this theorem to, we can extend this idea actually to other animals, or even in case of more than two choices as well. Another thing is, we have this kind of functional equation, we introduced this, but there is a natural question arise here, which we propose in our different published papers. And the question is, assume that an animal did not make a choice. It means that fish started from here and didn't make a choice and coming back. And that is called, in psychology, that is called the bounce back situation. It means that the animal didn't make a choice and coming back to its original point. Then that kind, to discuss such type of situation, we added an extra term in our functional equation so that we can cover such type of thing. Because when we have the video data set, we observe such type of thing, because in some trial, rat or fish didn't make a choice. So in that case, we need to modify our functional equation. So you can introduce a new functional equation in that case, or generalized functional equations. We use the fixed point theorem, but you can use different, for example, we use the Banach fixed point theorem, but I told you that that paper has more than 7,000 citation. It means that there are many extensions of that theorem. So you can apply any other kind of fixed point results to the same functional equation. It means that you can keep the same functional equation and use another fixed point method. Another thing is the stability. We didn't discuss the stability of, actually in some papers we discuss the stability of a fixed point, but we didn't discuss the stability of the proposed functional equation. So you can work on the stability of the functional equation, for example, Ulam and Harris type stability, or some generalized stability results as well. For example, if I discuss here, for example, this paper, what they did in they try to extend, or they try to change the functional equation. Okay, the easy extension, I can say that you do not need this one, make it journal. And here also, for example, this can be G1 and this can be G2 of x. So our functional equation will become, for example, z of x equal to x, z of G1 of x plus 1 minus x, z of G2 of x. And then put some condition on G1 and G2, what type of mappings these are. For example, you can say that G1 and G2 are Lipschitz mapping, okay? Or some continuity condition on that thing. Another thing is, as I told you, that we use the fixed point method, but you can use, there are different methods as well, but you can use different method. For example, in this paper, the author use another method, which is the collocation method on the same functional equation. Okay, so they keep the functional equation and change the method, and then you can compare your method with the existing one. Another thing is, I told you here that we use the Banach fixed point theorem, but there are different fixed point theorems, you can use them on the same functional equation. This paper published very recently in 2025, and they use another kind of fixed point theorem, and they apply the theorem on the same functional equation. Okay, all these are the extension in terms of mathematical extensions. Okay, if we talk about machine learning extensions in terms of data science, so what we can do is we can use such type of ideas in understanding the animal behavior. For example, in with the help of 3D motions. For example, what animal is doing now, eating, jumping, sitting, walking. So these are all kind of behavior for animal behavior, and then we can classify them, predicting and classify them by using different machine learning methods. And for example, this paper, Deep Learning Tools for the Measurement of Animal Behavior in Neuroscience, published in Current Opinion in Neurobiology. You can read this paper. And this is another paper, Animal Behavior Classification by Deep Learning on Embedded Systems. You can read this. Also, if you want to work in terms of real data set, not on the machine learning plus analytical model. If you are interested only on in terms of machine learning. This is our paper in which we observe or we discuss both things: analytical solution plus the machine learning validation. This is our another paper we published very recently in the beginning of this year, in which we use the deep neural network and stochastic method for the cognitive modeling of rat behavioral dynamics in T-mazes. In this paper, we also use both methods, analytical solution plus the machine learning solution. Oh, okay. So here are some announcements. Actually, this is our book, which is soon it will be published in IGI Global. It is related with the computational and deep learning models for advanced behavior analysis, behavior for anything. For
You are now
and
muted.
evaluation. So all these are the things, and this is another call for papers published, which is the special issue in Fractal and Fractional Journal, which is in Q1 MDPI, hybrid modeling approaches, deep learning, and differential equation in complex system. So if you have anything, please let me know. And if you have any question, please, you can ask me, or you can send me an email here on my email ID. Okay. And I will try to answer it. Thank you so much. And if you have any suggestion or comment, please let me know.
You are now unmuted.
Okay. Okay, sure.
You are now muted. You are now unmuted.
Okay, thank you for
You
the
are now
question.
muted.
Actually, we until now we work on different type of animals. For example, fish behavior in a fish tank, and then I already showed you one paper related with the rat behavioral dynamics in TMSs. We already work on the behavior analysis of these two animals, but uh, we have submitted one paper in neurocomputing. It is about the behavior of a dog in a shuttle box operators by using some deep learning methods. This is and two or more methods. If we talk about machine learning, yes, these three or four papers we have. But for analytical techniques, like in mathematics, we have also around 10 or 12 papers in which we discuss different type of methods to solve such type of equations.
You are now unmuted.
Okay, for the
You are now
next
muted.
step, I will say that we are working on a device, actually, the end product, because the problem is we are working on a specific method to make a device which can predict and classify the animal behavior in certain circumstances. Because if you see this paper, I will show you one paper, this one. It is about animal behavior classification via deep learning on embedded system. In this paper, they make a device for cow, yeah, and they install it in a cow farm, and the device actually predict and classify the cow behavior in different situation. It can monitor even the temperature and other things as well. So we are working on it, and we are very initial stage, because the first thing is we need to fix our code and then compare it with different the existing methods.
You are now unmuted. You are now muted.
Thank you, and welcome.
You are now unmuted. You are now muted. You are now unmuted.
Our second keynote is by Dr. Firdaus Abdurrazak, an accomplished researcher with a dual PhD in information science and telecommunications engineering from Canada and Spain. Her work focuses on antenna design for biomedical applications, electromagnetics, and wireless innovation, with applications in wearable devices, wireless power transfer, and healthcare technologies. She has also been a mentor, educator, and contributor to multiple international collaborations, including organizing graduate competitions and workshops through Staracom. Her technical expertise spans across tools like MATLAB, FECO, CST, and advanced data visualization techniques. Today, she presents her keynote titled Next Gen RFID Antennas Innovations, Uses, and Technical Hurdles. Ma'am, over to you.
You are now muted. You are now unmuted.
So I hope that you're hearing me
You
now.
are now muted. You are now unmuted.
Thank you so much.
You are now
So
muted.
thank you for this beautiful presentation. And I would like to thank Professor Kishore Kumar Reddy for inviting me for the Engineering Conclave 2025 organized by the Stanley College Engineering and Technology for Women. So my today's session is actually an extension or like an extent for my PhD project. So this is actually what I'm going to work for. And I'm presenting over here something that could be very important maybe for people who want to submit scholarships for Canada or people who want to make cooperation with some universities in Canada, since the topic here is very trendy. So my session for today is entitled Next Gen RFID Antennas, Innovation Uses and Technical Hurdles. This presentation is presented by myself, Firdaus Abdurrazak, and here is like our outline for today. So in the first place, I'm going to start by an introductions, and in the second place, I'm going to start the innovations in RFID antennas. Later, we move to the real-world applications of RFID antennas as well, and in the fourth place, we find the technical hurdles. Later, I cite some future outlook, and we finish by the conclusion. So for the introduction, we may find like three important parts, which is the brief overview of RFID technology, why antennas are critical in RFID performance, and of course, the industry demand and market trends. So actually, the first question, what is an RFID technology? So RFID technology is a wireless communication technology that enable automatic identification and data exchange between reader and a tag using radio waves. So an RFID system consists of three main components, as we can see over here. So if we are going to start by the reader, which generates and transmits radio frequency signals. Later, we have the tag, the RFID tag, as we can see here, which includes a microchip for data storage and an antenna for communication with the reader. And by the end, after the reader like detects the tag, the back end system process collected information. So here, from the technical point of view, the reader could be as well called the interrogator. It consists of antenna, RF transceiver, MCU, decoder, power, and network interface. And for the tag, like which is as well the transponder, it consists of an antenna and microchip, and we can find in the industry in the global market uh, three big categories of tags. So the first one are passive tags, which just like powered by the reader's RF signal, and their characteristic is that they are cost effective, but as well they have some limited range. We have as well the active tag, which are powered by internal battery. They have longer range and higher cost. And we have as well in the third place the semi-passive, and some people call them as well the hybrid, which battery assists cheap but communication via backscatter. So here, if we are going to consist RFID frequencies, we may find like usually there is even like a radio frequency, but usually the most used in the international market are the LF RFID, HF RFID, and UHF RFID. For the RFID, we have the frequency between 30 kilohertz and 300 kilohertz. And the typical used frequencies in this margin is 125 kilohertz and 134 kilohertz. And the read range could be up to 10 centimeters. Usually, LF RFIDs are use passive tags. So here we can say that as well, the data transfer rate is slow. When I say slow, moderate, or fast is when I compare the three kinds like of a frequency range. When I compare the data transfer rate of each category of frequencies. For example, for the HF RFID, the frequency is between 3 megahertz and 30 megahertz. And the typical frequency which is used in industry is 13.56. And the read range is between 10 centimeter and 1 meter. They are as well usually passive. And we can say about the data transfer rate moderate when compared with the previous one. For the UHF RFID, the frequency margin is between 300 megahertz and 3 gigahertz. And the typical used frequencies are 860 megahertz and 960 megahertz. The read range is up to 12 meters, which is really important and very like this is a very wide range for the people who are used to RFID technology. And the UHF RFID use passive and as well active tags. We can say for the UHF RFIDs that they are the faster from the point of view of the data transfer rates. So here, why antennas are critical in the RFID performance? We have just seen that like RFID could be like characterized by band of frequency. And of course, when we speak about frequency, we speak about antenna. So the story here, why the antenna are critical in RFID performance. And here I'm going to give the main ideas for someone who is not used to this technology. So first of all, like power transfer, especially in passive tags. Passive tags are very interesting in industry and now as well in research because they don't have any incorporated like battery. They are just using the RF field of the reader. So the passive RFID tags have no battery. They rely on the reader antenna RF field for energy. A well-designed antenna maximizes energy transfer to the tag, extending read range and reliability. As well, on the other side, poor antenna design will include weak coupling, and the tag will not be powered properly. And here we speak about the interaction and the coupling between the transmitter and the receiver. So in this case, we can say that our transmitter is the reader and our receiver is the tag. And later we can check the S21 and we can know whether the power transfer between the transmitter and the receiver is taking place or not. These are as well some basic technical things to know about RFID communications. And the other side, an important criteria is the signal strength and read range. Antennas determine how far an RFID reader can detect a tag. So larger directional or array antenna can increase range, especially in UHF systems. So as well, in the other side, we have to know that small and poorly matched antenna limit range makes the system less effective. So we have as well another very important criteria, which is the frequency dependence. The RFID works at, as we said now, and as we have seen, at three different margin of frequencies, which are LF, HF, and UHF, or sometimes, as I said, microwave bands. And antenna design must match each frequency. So, for example, for the LF and the HF, there is inductive loop antenna near field coupling. For the UHF and microwave, we can use dipole or patch antenna, backscatter, and far field. So antenna mismatch causes loss of efficiency and interference. So here, as we can see the three types of the three types of frequency margin, and we can see as well the related antenna system. So here, the first one, the LF or the HF, we can see the inductive loop antenna, for example, for a card, a magnetic card, which are like widely used in universities and administration and everything to have access. And we have the UHF as well, dipole antenna. And we have the microwave patch antenna. I'm going to speak later more about the application of each one of them. So here, as we can see, some example of RFID antennas, yes, by the frequency band will maybe like familiarize the idea more and give more insights. So for the LF and the HF, we have the inductive loop antenna near field coupling. So example, this is the card of HID. This is a very cheap card actually. It costs only 3.5 Canadian dollar in the market. So these kind of cards, they are widely used. They use LH and LF and HF antennas for RFID technology. And they use a coil, a loop antenna embedded in the card. They are common, as I said, they are usually used to access control badges, animal tagging, insecure identification. They operate, of course, in LF and provide a strong penetration through water and metal, but limited range. As we said before, when the frequency is lower as well, the range is lower. The other example that we can take over here is like the MIFAR Classic 1356 megahertz smart card. And here they are built on inductive coupling with loop antenna in the card as well. And they are widely used in public transport, contactless payment, and library cards. So here's the goal of presenting some industrial examples, because we have to know as well when we do some research, or when we do some research PhD master, it is good to check what exists on the market, because actually we need some solutions for the problems that we have right now. Sometimes we see people are trying to redo something that they already exist, and this is a very bad idea. So the better thing is to check what we have in the market, how much they cost, and me as a researcher, what would be my challenge in that. So these solutions are widely used in the market. You are going to see later their challenges and everything. But I would say always when you are doing research or when you are going like you're doing your career as an engineer, check what exists in the market. So the day you are going to propose a proposal or you're going to write your proposal for a scholarship, you know that you're giving an additional value compared to the things that exist in the market. So here, for example, as well, an example of RFID antennas, as we said, by frequency band, we move to show some UHF. And as I said before, the UHF are mostly dipole antennas. They are as well existing widely in the market. Here, an example of alien technology. And this antenna, for example, it has a full data sheet. It is like very well described, and students can access to the links or to the industries, and they can have an idea about the designs of antenna. Like they have even more detailed antenna, detailed description of the antenna more than papers. So you can go there and check, for example, this alien technology antenna, which is thin printed dipole antenna design. It is widely used in supply chain, logistics, and retail inventory tracking. It is optimized for long read range up to 10 meters. And when you check the antenna as well, you can see that it is respecting some international requirement. For example, this one, as we can see, it is respecting the ISO. Because when we speak about RFID or we speak about magnetic field, there is some international criteria to be taken into consideration in order not to cause harms to a human being or to the animal where we are going to apply or use this device. Another type of antenna which is widely used in RFID performance are the microwave patch antennas, which are usually used for far field and high frequency. And this is an example of microwave antenna, which is actually a reader. So its application includes tool collection, vehicle identification, and high-speed asset tracking. As well, microwave operation gives fast data rates but reduced penetration through liquid metal compared to LF and HF. And could be easily explained why. Because when we speak about dipole, when we were speaking previously about coil antennas or dipole antenna in this case, we can see that there is a magnetic field behind. So the penetration for sure is going to be higher. However, for this kind of the patch antenna, the penetration is the system is not mostly using a magnetic field. It could be using just RF field. So here, of course, the penetration is not the same. And I have to say that it is more expensive than the other system that we have been showing. This is its cost in the Canadian market is $1,905. So in summary, we can conclude this small summary, this small conclusion in the beginning of our introduction. So the LF and HF loop antenna, they are used for access control badges, smart cards. The UHF dipole antennas, they are mostly used on retail logistics inlays. And the microwave patch antennas, they are using in tooling and vehicle ID system. So as well, the antenna has a lot of specification, technical specification, but we can't use, for example, the RHF loop antennas and the vehicular ID system. They as well impact the application of the RFID system, and because of their performance, because of their ranges. So here, why as well? This is we finish it from the different times, from the frequency point of view, how the frequency gives us different margin of frequencies, and how those different margin of frequencies give us different antennas, and how these different antennas give us different applications. But there is other point to be considered when we are speaking about the antenna in RFID performance. So over here, we have to know that the tag orientation and polarization is very important. So the reader and tag antenna must have compatible polarization, linear or circular. If a tag is rotated differently, it may not be read unless the antenna is designed for polarization diversity. And engineering optimization ensures performance in real-world conditions like moving packages, etc. As well, the environment and the materials. Antennas are sensitive to metal surfaces, liquids, and the electric material. These can detune or block signals. So engineer design specialized antenna on metal tags, flexible printed antenna, etc. Another important point, which is the scalability and application. Antenna arrays allow for coverage of large areas, warehouses, retail shelves, and beamforming or phased array antenna improve accuracy in locating tags, RFID localizations. So these are as well why the antenna system is very important in RFID performance. It doesn't only impact the geometry or the configuration of the antenna or the application, but we should know that as well the antenna system and the tag of the tag and the reader in the antenna system in total, they are very well connected, and they have to be compatible with each other's and match it. So now, after we have seen the different characteristics of RFID from mostly technical point of view, so what about the industry demand and market trends? So yeah, I can tell you that this is one of the most growing markets in the world. So the RFID market is on a strong upward trajectory through the scale and pace, very depending on the source. So market and market, this is This is a very known statistical website. Expects that the global RFID market to grow from 12.61 billion Canadian US dollar to 25.24 billion US Canadian dollar by 2023. So here, if we are going to consider the compound annual growth rate, it is equal almost to 9.1%, which is so huge. So I have to as well to highlight that this statistics didn't just take into consideration like random data, but it was based on some specific ecosystem analysis based on many companies. For example, RID, it was Zebra, HID, Honeywell. From the manufacturer, it was like Eximilco, and from the end users like Amazon, Decathlon, Walmart, Zara, and these kind of companies which are known on the international level. So here, the key radio frequency technologies companies, we have to know that as well there is a concentration where this market is growing up. And since I think you are in India, so I wanted to highlight today that maybe because we know that Indians are very talented and they have many ideas, and I see them always in the Canadian labs. It is important as well to think about the RFID as a research and as an industrial like field of discovery and of improvement. So the following are the leading companies in the radio frequency identification technology markets. These companies collectively hold the largest market share and dictate industry trends, as I said them before in the previous slide. And here we can say that the radio frequency identification technology market has the largest market in North America, which is like almost 37.6%. So this is an important information to know that this is a very growing market, and it is like impacting a lot the industries over here. So what are the emerging trends? If the market is looking for the improvement of the RFID technology, so actually, what are the emerging trends? So we can speak shortly about the AI-driven RFID analytics, which are now very like widely used in the market, and I hear this word a lot with machine learning as well for RFID analytics. So using RFID generated data for predictive maintenance, inventory optimization, and fraud detections. As well, smart warehouses and automation. RFID is a key component in next-gen warehouse combined with robotics and AR to enhance real-time visibility and reduce manual errors. Adding to that, sustainable and reusable RFID component, companies like Checkpoint Systems are innovating with microwave safe and reusable RFID. Reusable RFID inlay supporting circular economy principle, or as well we call it like green RFID. So scalable and cost-efficient manufacturing. Tagios ramped up RFID inlay production to anticipate growing demand. This is Tagios is one of the biggest companies as well, which has like a big sector on investigation and fabrication of the RFID. So they launched an innovation center focusing on flexible IoT integration like sensor and PLU. RFID experimental shipless tags aim to reduce costs dramatically compared to standard RFID tags. They hold potential for large-scale, low-cost application if environmental robustness improves. So as well, very important thing as well in all antenna technology is miniaturization advancements. So development of ultra-small RFID chips like reaching the level of 0.05 by 0.05 millimeter units allows for embedding and diverse items through antenna integration and range limitation remain challenging. So here a small summary as well about the RFID market and industry outlook. So we have from the international market growth a strong upward trajectory. Demand diverse operational visibility inventory, lot of application as we listed before, and the key trend is just to the key trend is the last things that I have said. It's about like smart warehousing, AI analytics, reusable tags, shipless low cost labels, and etc. So now we can move to the second part of this presentation, which is about the innovations in RFID antenna, which will be discussing three important points: the new material, miniaturization and integration, case studies for industry. So, new material and flexible printable metamaterial aided. So here, as we can see in this page, flexible substrates are used as well for the fabrication or for the manufacturing of RFID antennas. And here, when we speak about flexible substrates, we speak about PET, polyamide, paper, textiles. So, what is the interest of using this kind of materials? Is it just to enable bendable thin antenna for SPAC packaging and wearable? So here, as we can see in this figure, which is like I put the reference, it's from academia. So the schematic illustration of the process, A presents the schematic illustration of the process, the close-up view of the electrolyte meniscus between the printing nozzle and the substrate. And figure B, we can see the schematic of the conventional bulk electroplating process is shown for comparison. Later, the schematic shown C is the schematic shows the hybrid process for printing pure metals on a flexible substrate. And D and G photographs of various metal. As we can see here, they are nickel and copper patterns printed on flexible substrates. And these are, as I said, widely used on smart packaging and wearable. So as well for the new materials, we can see that another like trending technology is using printable material aided. So here there is like some specific printers that can provide like very efficient RFID. So printed electronics like conductive inks, and there is many technologies via screen, inkjet, gravure, flexo printing. What is the interest of this technology? This technology is very low cost and scalable production. So as we can see here for the first picture, it is the green UHF RFID tags, gold and B sample being printed with the Epson 2010 W printer. And as well, this print or this RFID, this tag of RFID antenna could be measured with a vector network analyzer. So even like the fabrication or sometimes even the measurements of some RFID antennas could be easy thanks to this new technology. And this is what we call as well green UHF RFID tags. As well, we can see that there is a wide use of a new material, flexible, printable, metamaterial aided. And here, for example, an example of artificial magnetic conductors and meta surfaces. Why this technology is used now? Just because it improves read range on metal liquid surfaces. So over here, we can see a metamaterial inspired AMC-based dual band antenna for USM and RFID application. So after this, after we have seen like the previous section, we move to the miniaturization and integrating with sensors. So we start with the techniques of miniaturization first. So we can see we have the first technique, which is really widely known, fractal antenna. The concept of this technique that antenna is patterned with self-similar fractal geometries, which achieve long electrical length in small physical space. For example, here we have the prototype of medicine blister with UHF RFID tags integrated with aluminum foil. The first one has 0 fold slot, while the second one has 1 fold slot. As well, the techniques of miniaturization include meander lines, and their concept that they are folding antenna path into meandering lines to reduce footprint while keeping resonance. This technique is very widely used in library books or credit cards where a thin and compact antenna is required. As well, the slot loading, which are like adding slot cuts into antenna patch to lower resonance frequency. So it is like kind of miniaturization without external size increase. So this is actually an example of UHF Gen 2 on-off metal RFID tag, which is especially designed for metallic asset tracking indoor, outdoor, or extremely harsh environments. As well, after we checked like why we need miniaturization technique for RFID antenna and in which field they are like basically used, we should know that they are as well integrated with many sensors nowadays. So I'm going to cite some example. For instance, the temperature sensors with the RFID. So a thermistor or printed temperature sensitive polymer is coupled with the RFID IC. The tag modulates its response according to the measured temperature. Use case, cold chain logistics, smart medicine bottle, and industrial monitoring. So, industry example, Avery, Denison, and SmartTrack developed battery-free RFID temperature labels for pharmaceutical logistics. And here we have actually a very industrial example that exists already in the market. As well, RFID could be integrated with humidity sensor. So, hygroscopic materials or capacitive humidity sensor integrated with the RFID chip detect moisture level and the use case in these cases include food packaging for alerts and perishable good exceed safe humidity limits, pharmaceuticals, protecting tablets, capsules sensitive to humidity during storage, and even cultural heritage monitoring humidity in museums, archives to preserve documents and art. So, and as well, this is already used in the market, and this device, everyone actually could buy it for a very cheap cost. Another very important, it is the strain sensors, which are integrated with the RFID as well. So the antenna itself or an embedded piezo-resistive material changes electrical response when stretch is bent. The RFID chip here translates this into strain data, and it is used in sports and fitness, medical rehabilitation, structural health monitoring. So here, as I said, this is one of them. I would say this is a changing technology in the medical fields because maybe today I'm speaking about some sensors, but really in the medical field, RFID technology in general has changed a lot of things. And we are very thankful to this technology, like to mentor a lot of diseases, chronic diseases that we have nowadays, and maybe some people don't know. I hope that this technology reach different areas of the world and everyone can take advantage. So here we can see that zero power RFID based strain sensor for implemented fixator, like as you can see over here, the strain value over the fixation plate. And here we have like the strain sensor and the RFID batteryless and wireless. So as well, I gave some examples, but the integration with sensor is very wide. We have seen temperature sensor, humidity sensor, light sensor, but we have as well gas sensor, vibration sensor, leak detection sensor, proximity sensor, and shock sensor. All these kind of sensors integrated with RFID antennas, like they give a very good performance, very improved performance, tracking, traceability. It is like very advanced, and we hope that in the couple of years it reaches different corners of the world. So here the case studies. So we have the printed flexible antenna logistics retail. Here we have like the SmartTrack Avery Denison, as I said before. So they developed printed silver ink antenna on PET and paper, enabling ultra-thin, low-cost UHF RFID tags. So high volume screen, inkjet printing, and it is scalable for billions of items. Impact, mass adoption and global supply chains like Walmart and Zara. As well, this case of studies are purely from industries and existing projects. Like everything in this case of studies are innovations which were already made. So the second one over here is the material packet antenna on metal sagging. So Confidex Iran side uses AMC metamaterial structure to suppress image currents on metal surface. The innovation, compact design with robust read range, even when attached to metal, and the impact reliable RFID tracking of tools, vehicle, and containers in industrial environments. As well, we have a very important case of study in industry related to space constraining environments, which is like, of course, the miniaturized antennas, and Morota LXMS series has developed ultra small UHF RFID models with ceramic based meter and slot loaded antennas. The innovation over here is miniaturization without range loss. It means we always keep like the wider range of UHF and UHF RFID, and as well the integration in electronics, wearable, and medical devices. And the impact over here enable RFID tagging where conventional antennas were too large. So we spoke as well about the sensor integrated RFID antennas. So Freshness Medical Care has like developed a passive RFID with integrated temperature sensors for dialysis and medical suites. The innovation over here that their antennas co-designed with sensor powered by only by the harvested RF, so they don't have any battery, which is amazing. So they could be implemented in very complex environments. And the impact is monitoring patient safety without batteries. So the fifth case is energy harvesting antenna. So PowerCast and Willio developed battery-free sensor tags harvesting energy from ambient RF, which is Wi-Fi, BLE, or cellular. Innovation antenna optimizes for multi-band harvesting plus supercapacitor storage, and the impact enabled continuous monitoring of temperature, motion, and location without batteries. Here I have an example of case study. This is a video, but I don't think that we are able to check. But anyone who wants to have this presentation or wanted to see this video later, they can contact me in private, and of course I will update them with everything. So now we move to the real world applications. So the supply chains and logistic, warehouse automation, asset tracking, healthcare, retail, smart cities, and IoTs. We have seen all these kinds of things previously, of course, but these sections, like just to say this is the real application and to show it, like to put it on light. So here, this is the supply chain and logistic warehouse automation, automation, asset tracking. So as you can see here, RFID portals validate receipt of good and containers. So here RFID actually they are like located in different places or different departments of the company. So starting from here, it is like RFID porters which validate receipt of good and containers. As well, overhead RFID readers for pallet aggregation and kitting. The other thing that we have, RFID enable forklifts, verifies pallet contents and location. And as well, here, hand lift RFID, locate assets, scan exemption, verify location, and track service records. Here we have an RFID that enables shrink wraps station and verify and containing contacts. As well, we have over here RFID printing label, create item kinds and pallet label. And here we have like conveyor scanning, case and item verification. And we have as well, by the end of this, like the chain, we have like RFID portals which validate shipping of goods and containers as well. So here, from the reception of the containers, inside the shipping of the containers, like all the supply chain is like tracked and is assisted by RFID tags. We move now to the healthcare patient monitoring medical equipment tracking, and which now it's like one of the most important technologies based on the safety of RFID technology, and especially the innovations that we have, considering the materials, the flexibility, and the size, which could be like smaller when compared to other antennas. So here, the healthcare system actually doesn't include just that. Maybe when someone you talk to someone, okay, RFID is used in healthcare, they will say yes, maybe tracking of diabetes or something. No, it's not just like that. It is related to equipment. It is related to doctor. It is related to patients, and it is related as well to the infrastructures. So how RFID technology works in the healthcare sector, actually it ensures the patient tracking and identification, as well inventory management, medication management, compliance and documentation, as well as asset tracking. So we can see like it's a wide range of applications, and based on that we have a lot of advantages of RFID in the healthcare. So we have enhanced security, compact size, efficient access management, improved convenience, and a lot of advantages, as I said, related to the overall chain or the overall healthcare system. So let's now speak about the real world application from the retail point of view. So here in the retail, we can speak that we can say that there is 10 global brands that use RFID technology. And here, when we speak about retail, we speak about smart shelves and anti-counterfeiting. Here in Canada, actually, we use it widely. Like it is like when you go even to the supermarket, Walmart is one of the very known supermarkets. You can see RFID tags everywhere. So Walmart uses RFID for its retail operation. Zara uses RFID for enhanced inventory management and customer experience. H&M streamlining stock management with RFID. As well, Nike offers personalized customer experience with RFID. Adidas leverage RFID for its retail stores. Pfizer using RFID for anti-counterfeiting. Disney using RFID for ticketing and access control. Tesla using RFID for smart key cards. Amazon using RFID for Amazon Go Just Walk Out stores. P&G using RFID to track products. So we can see that now RFID is widely used in big industries, and for sure when especially it will have like more affordable prices around the world, it will be used in more companies in a lot of countries. No. So we never as well. So when we see the previous things, how RFID is used on industry, how RFID is used in healthcare, how RFID is used in big companies around the world. So these all the things that I was saying, they are like a part of this society, a part of these cities. So the smart cities and IoT, RFID used to access control, as well waste management and inventory or real time. So here, as we can see, for example, for the use, like the general use, we have the healthcare, the smart business, fire detection, traffic management, field supervision, parking system. All these datas, you like based on the RFID, or thanks to the use of RFID, they can give like very important data collection, and this data could be related post-processing for data analytics for the well management or the improving management of smart cities. Even like the smart waste management, like which I think is very nice idea. So smart bins with real-time monitoring like are used to dynamic routing for garbage trucks. And this way we can enhance and recycle circular economy as well. So now we move to the part speaking about the technical hurdles of RFID technology. So the first hurdle over here is the performance in complex environments. So the complex environments, first we are going to speak about the nature of the environment. So RFID signals are strongly affected by metal surfaces, causing detuning and image currents. Liquids absorb RF energy, which reduces read range and unstable performance. As well, the multipath propagation in warehouses or factory leads to fading in anti-system reads. So here, some example, maybe you may understand the case better. The tags failing on metal tools unless AMC material baking is used, and which are like more expensive than usual material. In retail, liquid filled products, cosmetic, beverage often show weak or no reads. The other performance in complex environment is not just related to the nature of the environment. It is as well. It is connected to the interference with the other wireless system. So if we speak about the UHF RFID band, it's like from 860 to 960 megahertz, which overlaps or adjacent to cellular bands. As well, the HF RFID, which is 1356 megahertz, can interfere with or be affected by industrial electronics. As well, dense RF environments, factory, airport, retail stores with Wi-Fi, 5G create cross interference. This is an example. For example, in airport, RFID for baggage tracking must coexist with Wi-Fi access point. And in smart retail, UHF RFID sometimes overlap with security system or BLE beacons. Another challenge, and which is maybe as well very important, is the cost and scalability issues. So the cost pressure, so here we have RFID tags must remain ultra low cost, a few cents each to be available for billions of items. So material, silver inks, and especially substrates raise costs, especially for advanced printed antenna. So here the manufacturing high volume printing processes, screen injecting graver, must balance through vs resolution vs current temperature. From the point of view of scalability, producing billions of tags with consistent performance is difficult. Variability is printing and substrate quality affects yield. So we have here some example retail industry. Walmart and Zara require billions of tags per year. Even as 1 cent cost increase becomes prohibitive. Sorry. Printed electronics. Inkjet printing allows flexibility but is too slow for mass production. Rubber is faster but costly to set up. So here, many startups fail to scale lab prototype or flexible metamaterial antenna into cost-effective mass production. As well, we have like another challenge or technical hurdle, which is related to sustainability and recycling or RFID tags. So we have to mention here there is an environmental footprint. So conventional RFID tags use plastic substrate, PET and BA, as we said, and precious metal, silver, copper, and antenna. Recycling issues, tags are often attached to paper, cardboard packaging, making it hard to separate plastic films and metallic inks during recycling. Waste problem with billions of tags deploying annually, the cumulative waste stream becomes significantly if tags cannot be efficiently recycled or composted. Example, retail and e-commerce tags are disposable packaging, millions of non-recyclable labels daily. Food packaging, RFID analyzes tag to cardboard boxes, contaminate the paper recycling stream. Industrial use, many packet tags contain multi-material layer adhesives, fluoride plastics that are hard to recover. So here, based on the technical hardware, we are going to check some future outlook of this technology. So one of the most future outlook and that the research now is working on, not only research in industry, is the integration with 5G and 6G and IoT platform. So the trend here, RFID will no longer be standalone. It will act as a seamless IoT layer integrated into next-gen wireless networks. What this means? So 5G, 6G provide massive connectivity in intra-low latency, enabling real-time RFID tracking across entire supply chains. RFID sensors become part of digital twins for factories, cities, and healthcare system. Here, an example, smart warehouses where RFID tags directly synchronize with 5G IoT gateways to update cloud dashboards instantly. Another very important future outlook is the AI driven RFID data analytics. So the trend that is RFID is generating massive data sets, item location, movement, environmental condition. What this means, AI or even ML like machine learning will turn noisy tag data into actionable insight, inventory forecasting, anomaly detection, predictive maintenance. Antenna performance itself may be optimized in real time with AI-based signal processing. Example, retain using AI to detect unusual stock movement, preventing theft and predicting demands. And the green and biodegradable RFID solutions. So the trend is to sustainability pressures push for eco-friendly antennas. What this means, antenna on paper or cellulose substrates using carbon or graphene inks instead of silver, fully biodegradable or recyclable tags designed to disappear with packaging. So here an example, printed paper-based RFID for food packaging that can be recycled with contamination. So for the conclusion, here we finish by saying that the key takeaways from these presentations, antenna are the heart of RFID performance, driving range, reliability, and integration. The innovation in material miniaturization and energy harvesting are pushing RFID towards smarter, more flexible, and battery-free system. The real-world adoption is accelerating across logistics, retail, and smart cities. As well, we have open challenges and opportunities for research and industry, like technical hurdles include performance in harsh environment, interference, scalability, and sustainability, which remain active areas for research. Future outlook, integrating with 5G, 6G, AI-driven analytics, and green RFID solution will reshape how RFID is deployed at a global scale. And opportunity exists for academia and industry to collaborate on making RFID smarter, more sustainable, and universally connected. So here, thanks for your attention. And if you have any question, you may ask me, of course.
You are now unmuted. You are now muted. You are now unmuted.
Ma'am, which of the applications do you think in the next 5 years would be most used for RFID?
You
Okay,
are
I'm
now
going to
muted.
answer about this question. So, for example, I know from my lab in Spain. Okay, we have very potential. Like I was speaking with my supervisor and everything, like my supervisor in my PhD, and they were telling me like all the projects that they're having lately are about RFID. So one of the things that we have, like we have many obstacles and many challenges that I was reciting over here in the presentation. And actually, if they will be solved, of course, like RFID will be more used. But here the question where it will be more used. So it depends. For example, in Canada, it is widely used, in Europe as well. But in my country, for example, Tunisia, we use it just in the supermarkets mostly. And now we have the tags as the new standards of tracking for children and everything. So of course, it is very increasing, and RFID will be more used. But now we are as well, like science is interested on more challenges, solving more challenges related to the especially to the technical hurdles. And if they are going to be like solved, of course it will be more used. But depends where exactly, depending on how it is already used now.
You are now unmuted.
Like what should students focus on right now to grow in the field of RFID?
So for the students, you mean
You are
engineering
now
level
muted.
now?
You are
Because
now
I'm speaking to
unmuted.
engineering level.
Yes, yes, ma'am.
So this is why I tried to make like
You are
the
now muted.
presentation not very technical. I wanted to make it so simple so the engineering students can reach something from this. So what I advise engineering students to do, guys, over there in the internet, you have a lot of data sheets. You have a lot of products. Go to these products, download this data sheet. You have a lot, you have access to different platforms as the students, like different software for sure in the university at least. Try to redesign this structure. You see an RFID tag, okay, I'm going to redo it by myself. Give yourself a task. This is your task maybe for the coming 6 months. You have to learn how they function. It is easy to see them. It is easy to say, yeah, it's not very complicated. It's just a coil antenna. But while designing, you understand there is a lot of complexity. There is a lot of challenges to design, like these kind of RFID tags or RFID antenna in general. So what you should be as engineering students, go to the existing industrial example. Don't go to research, go to industrial example. It doesn't mean that research is not good. Research is good as well. But industrial examples are the ones that are efficiently used. So go to this example, redesign them, check them. You have some maybe challenges. Check your professors. It will be nice to understand how they work from the basics. So thank you. This is my answer.
You are now unmuted.
Thank you so much. Have a
You are
great
now
one.
muted. You are now unmuted. You are now muted. You are now unmuted.
We'll continue with our third keynote session after a short break. Thank you.
You are now muted. You are now unmuted.
Our final keynote this evening is by Dr. O.T. Arogundade, Professor of Software Engineering at the Federal University of Agriculture, Nigeria. Dr. Arogundade leads the Smart Agro Research Cluster and holds a PhD in computer software and theory from the Chinese Academy of Sciences, Beijing. She has been a recipient of numerous international fellowships, including the OWSD Postgraduate Fellowship, AMI Mahan Research Fellowship, TWAS, DFG Postdoc Fellowship, and more. She chairs the ACMW Ibadan, Nigeria chapter, and her work spans over 90 publications, contributing significantly to software engineering, research collaboration, and empowerment of women in STEM. Today, she will present the role of women engineers in shaping future technology, an essential conversation on representation, leadership, and innovation. Let us give a warm welcome to Dr. Arugundade. Ma'am, over to you.
You are now muted. You are now unmuted. You are now muted.
Hello?
You are now unmuted.
Yeah.
You are now
Arogundade, I
muted.
want to share my screen. And
You are now
I've
unmuted.
uploaded my presentation. Can you check my presentation on your uploaded files?
You are now muted. You are now unmuted. You are
Yes,
now
I've
muted.
uploaded it.
You are
Okay,
now unmuted.
thank you.
You are now muted.
Yeah, thank you very much. Israt, thank you
You
for
are now
the
unmuted.
introduction, and I'm happy
You
to
are
be
now
here and to be selected as one of the keynotes for this enclave, and I will try my best to make the presentation within the time permitted. I think I have 45 minutes.
You are now unmuted.
I have 45 minutes. Is it 45 minutes or 1 hour, 15 minutes? Okay, 1 hour,
You are now
15
muted.
minutes. Thank you very much. The topic of my presentation is the role of women engineers in shaping future technology. Normally, cutting across the board in the whole of the whole world, we discover that the role of women is very, very important when it comes into shaping future technology. But unfortunately, we have the number of women in technology not as many as that of men, but we still have our role to play because we have women that are also doing very well in technology, and they are inventing so many things into technology, and we are shaping the technology using our power as women. Yeah, we have many women engineers worldwide. Most especially, we have some in India, and we have from China. We also have from Africa too, that have made contributions worldwide to engineering and science, technology altogether. I will mention some of them, and then we will see that women are really trying all their best. Why this topic? Why does it matter? This topic matters a lot. Personally, as the facilitator of ACMW in Nigeria Professional Chapter, I always organize program to promote uh, computing as a career among girls in high school, among ladies in university, because inclusive tech will give us better solutions for all. If technology is not all inclusive, men, women, well represented, we may definitely not get better solutions for all. So bridging the gender gap will definitely unlocks untapped potential that women, one way or the other, because of our involvement in family matters, community matters, religious matters, we may not be as active at times in technology promotion like men, but at the same time, it is only inclusive technology that can give us better solutions for all. And that is why having ACMW is very, very important, because we accommodate women, and women has the freedom to exercise their potentials. They have the freedom to also display their potentials, especially in innovation and technology. So inclusive technology is the solution for all challenges. So the bridging of the gender gap will unlock untapped potentials. Diversity also drives innovation. Inclusive technology is equal to better solution for all. You have creative breakthroughs, then teams with gender diversity outperformed by 15%. That's by McKinsey. McKinsey said, when you have teams with gender diversity, definitely it outperforms having a kind of team which where you don't have gender equality in terms of women, men, then you have the black, you have the white. So when you have the gender diversity, definitely, according to McKinsey, it outperforms by 15%. When you have women, you have men, you have creative breakthroughs. So diversity drives innovation. From experience, working with different people from different places, from different countries, I have discovered that diversity drives innovation. Having my PhD in China, that is a graduate University of Chinese Academy of Sciences. I discovered that when I was there as a PhD student in 2009, I have cause to work with my Chinese colleagues on a particular project, which was an international grant won in my institute at that time. I gained a lot with the diversity, the way of thinking of different people, I gain a lot. And actually, that marks the beginning of my breakthroughs in getting grants to carry out my project. That marks the beginning of my breakthrough in getting grants, the way proposals have been written, the thinking, innovative ideas. I discovered inclusive tech, really, in the real sense, is a better solution for all. And when you have people from different diversity, I conform and I agree with Mike Eason that definitely the team will outperform by 15%, according to his findings. Historical overview of women in engineering. Ada Lovelace, the first computer programmer. Can you imagine that? It's a woman. Grace Hopper, which we celebrate today in Google, invented the first compiler. Eddie Lama developed wireless tech base. Radia Palmer invented spanning tree protocol. On and on. We still have some of them like that have done a lot to make sure that we have technologies to address the challenges that we are having in computing, in engineering, and in other domains, in digital humanities. We have women that are really doing great. Present landscape of women in STEM. Only 28% of STEM workforce are women, UNESCO 2023. You can see that this percentage is very, very low. Very, very low. That's science, technology, engineering, and mathematics. According to UNESCO 2023, only 28%. In engineering, just 16% are women. Underrepresentation in leadership and patents. Women must be encouraged. We can go a long way to provide better solutions to to challenges in our communities, in our countries, in our continent, and so on and so forth. Looking at this landscape and the percentage of women, why do women matter in engineering? Why do women matter in engineering? We have diverse teams, which will bring better outcome. Diverse team, better outcome. Then we have, I would like to have my full screen, okay, don't worry. We have product design, car safety, AI recognition, that's product design, we have car safety, AI recognition. We have real-life consequences of exclusion. So why women matter in engineering? Why? Why do women matter in engineering? Look at this. We have women leading in AI and emerging technology. Women are leading in AI and emerging technology. Fifi Lee imagined AI revolution. Gitanjali Rao lead detection tool. Swati Mohan NASA Mars mission. You can see that women can actually bring about better solutions when they team up together with with men. They can come up with better solutions. Challenges facing women engineer. Challenges facing women engineer. Challenges facing women engineer. Gender bias and stereotype. Gender bias and stereotype. Work-life imbalance. lack of mentorship, leaky pipeline. Leaky pipeline. We all know that. We all know that leaky pipeline. One way or the other, some women, they face challenges and they seem to, one way or the other, leave the profession because of the challenges that they are having. They leave the profession. And then leaving the profession, you can see 40% leave the profession. The gender bias in some continents, when women wants to come up, when some women wants to come up with some other, with ideas, they want to come up with solution, you discover that maybe they are not allowed because of the culture or because of their belief in those areas. So we have that challenge, gender bias. When they hear about women, some people, maybe they're afraid. They feel that, oh, women cannot do it, but women are really doing it. We have seen samples and role model women that are bringing up solutions to challenges. Work-life imbalance is a major challenge facing women engineers, taking care of children, of families, and not having policies that are actually supportive of their career. They don't have policies that are supportive of their career. That is, in places where taking care of children, they are not given enough time to raise their kids, having places to keep their kids while they pursue their career. I mean, on and on like that. So these are part of the things that are challenging women from actually pushing forward. And that is why you have the percentage that we are actually having, thinking of 16% are women in engineering. And in science, technology, engineering, and mathematics, just 28%. Work-life imbalance. We have lack of mentorship. Lack of mentorship. Lack of mentorship. When you talk about mentorship, yes, mentorship are available, but at times the way mentorship will go on with women may be different from men. The men, they may have all the time out there to do what they're supposed to do, to have time to follow on with the schedule of their mentor, but at times because of the gender life imbalance, there may be some things that will definitely disturb women from being able to face what is to be done. I want to move to my next slide, but this is covering it. Okay, thank you. The gender tech gap. Gender tech gap. Algorithms failing women. Medical AI trained on male data. Urban planning lacks female perspective. For women to actually be very, very active and to be able to come up with their solutions to challenges that we are having, this gender tech gap must be closed. You can imagine medical AI trained on male data. What of female? Urban planning lacks female perspective. But from beginning, like I said, when you have diversity, teams with diversity, gender diversity, you have better solution. When your teams are just majorly male, it may be a bit difficult for you to really get better solution. That's the truth. And those are facts from research, from survey, for that we need to consider in whatever we are doing when you are talking about the role of women engineer in shaping the future of technology. They must be involved. Like in training of AI, medical AI, use female data. Then urban planning, when you bring in female perspective, you can have better urban planning for the whole city, for the country, because the perspective of women will definitely be different from that of men. Academia role in inclusion. In academia, there have been efforts to recruit and to make sure that the curricula are gender inclusive or all inclusive, including women in Nigeria. We just have our new CCMAs going through the number or the names of people that are involved in putting up the CCMAs. You discover that you have many women that are involved in the development of the curriculum by Nigeria University Commission. There's also hiring equity. In hiring, in recruitment, there should be equity. There should be equity. Yes, women, they spend longer years on their PhD, they spend longer years on their masters. Yes, they should be encouraged so that there will be equity. They should be aided. Yes, they should be encouraged with grants, scholarship when they finish their postgraduate, and then when it's time for hiring, they should also be considered in the condition of service so that they will be able to fit in like male. Mentorship and fellowships should be made available at the level of women. I'm not saying they may not be able to cope with the schedule, yes, especially for those that are at the stage of bringing forth, having children. So also training should be anti-bias. When you call on people to apply for training, either physically to travel or they need to stay back and then join virtually, women should also be considered. They should not be biased. It should be a kind of anti-bias training. Women should be allowed, and academia has this role to play. When they are involved, we will have better solution. Just like I've said at the initial stage of my presentation. Let's consider Carnegie Mellon University. They have their reform admissions and culture. Female computer science enrollment rose from 7% to 48%. Active mentorship and support programs were made available in computer science. So we will, the same way it is here, when you also come, in my own university, when you sample the number of ladies that are in different level, they are few, very few, when you compare it to men. But when all this, when they are encouraged, there's equity, and then they are aided, anti-bias training, mentorship and fellowship, grants are made available to women. You allow them to compete. Though you have many grants, women, it's not that they are inferior, but you need to consider them some things, the work-life imbalance and some other responsibility they are shouldered with may not allow them to actually be able to perform like men, but that does not mean that the intelligence is lower. The smartness is lower. No, not at all in any way. But when they are aided because of the additional responsibility, the women will definitely perform and we can have better results. We have industry interventions. I've talked about the academia, what can be done, involvement of women in curriculum, preparation, hiring equity, then anti-bias training, availability of mentorship and fellowship. That will definitely assist women. We also have some industry interventions that worked. Google's Women Tech Makers, Microsoft DigiGirs, Intel's $300 million diversity initiative, gender audits in AI. These are industry interventions that work, and this will help women to actually play their role very well in technology. There is need to create strong STEM pipelines. Strong STEM pipelines. We are not there yet. We need to get there so that children can be prepared from their primary schools to actually have flair for computing, for engineering, for science and mathematics. That is STEM. We need to create strong STEM pipelines. Strong STEM pipelines. We need to focus on primary and secondary schools. The grantors need to focus on giving out grants and fellowship that will allow STEM, that will allow us as engineers, women engineers, to focus on primary and secondary school. Encourage girls in coding and robotics. In ACMW Nigeria chapter, except for last year, we weren't able to do it. We have some, due to economic hardship. I normally host program in secondary school, high school. I call it advocating girls' career in computing. It used to be a kind of advocacy. I will go to secondary school, a particular one in a particular environment or community. Then every other secondary schools around the place, they will send their representative. All we do there, especially in ICT Day, which is third Thursday, I think, is it first Thursday or third Thursday in April every year. We go there, we encourage them. But if we have grants, if there are fellowships and grants available, we can go all out so that we start the work from primary school, introducing them, making them to come into engineering, teaching them and taking them through soft skill. ACMW Nigeria chapter, we have organized program for summer for our primary and secondary school girls. We try to teach them a particular soft skill. That one we did in 2021. We had that one, and many girls participated girls in primary school and secondary school to give them soft skill in computing. It's just to make them to have flair for STEM, so that as they're growing up, they also want to pursue their career in computing. We need to encourage girls in coding, robotics, and then we need to have role models in classrooms and media. Kudos to so many girls initiatives in Nigeria. There is one by Dr. Sapre. Dr. Sapre is in UI. He has his own NGO that is for girls, tech girls. So we have the ACMW in Ibadan, Nigeria chapter. We have, that's professional chapter. We have that too, advocating girls to study computing science. Importance of mentorship. Women supporting women. Men as allies. We ally with men. We can't do it alone. So women supporting women. Then we have cross-generational mentoring programs. Cross-generational mentoring program. We need that. So that when they see, when you talk about, at times, even girls in secondary school, in high school, university, they're already afraid. Can I cope? Will I be? When they see other women coping and they have this kind of mentorship programs, cross-generational, it's very important. Some may feel that it's because you are white. That is why, because your culture is different from my culture. That is why you are able to make it. And it's because this one is this one is that. That is why you are able to make it. No, not at all. So we need women supporting women. We need cross-generational mentoring programs. We also need men as allies. Funding women-led innovation. We need to encourage entrepreneurship. We need research grants for women engineers. We can't run away from it. When women have grants, the passion. They are passionate about what they are doing. Women are exceptionally passionate. Once they focus on something to be done, they are passionate. So we need research grants for women engineers. We need tech incubators and accelerator programs to be established for girls and ladies. Girls in secondary school, we need tech incubators for them. We need, not that they cannot compete. Oh, are we not computing? You have seen the first women that brought up about a compiler. The first compiler. We have Ada Lovelace, the first computer programmer. We have Grace Upper, who invested the first compiler. These are women. These are women. Research grants for women engineers should be encouraged. Tech incubator for ladies, girls in primary school, girls, especially in this part of the world, in Nigeria, in Africa. We need this incubator, tech incubators and accelerator programs from primary school. When you focus on them, we are sure that the future of tech is secure. And then the women can actually play their role to provide better solutions when we have diversity in team membership. Tech for good. These are women contribution. Femtech, that is earth for women. We have green, clean energy and green tech. We have inclusive apps, so many apps for underrepresented users. Inclusive app for underrepresented users. These are tech for good, and these have been created by women. 43% of STEM grads are women, AICTE 2033. India example in women-led tech. Like I said earlier when I started my presentation, I said that we have many women in India that are actually leading in technology. IS Harrows, Mars, Orbiter, women-led. We have Kiran Mazumdar Shaw, Rushi Sackville, India women that are actually leading in technology. These are good. These are very, very good. But for us to secure the future of technology, the role of women cannot be left out. And so we need to start from the primary to high school, on and on like that. So that by the time they are grown, they'll be able to pursue their career in technology, and then women, all inclusive solution will definitely be provided. We have women in startups and industry, female founders in bio, in fintech, edtech. We have, we should encourage VC funding to women-led startup. Example, NICA, BYJUs, Tech Leads. These are examples. So we should encourage funding to women-led startup. We have so many women-led startup, so many women-led startup. And if there are no funding for them, I've made available for women specifically, they may not really be able to continue. Okay, sorry. Previous slide. Smart cities and inclusive design. I said at the beginning of my presentation too, that women are left out in urban planning. You know, women perspective are very, very important. Women in civil and urban engineering, gender-aware public tech. They are safer, smarter. Then we have inclusive city. We have safe, smarter, and inclusive city when women are involved in urban planning, in civil engineering. We can have safer, smarter, and inclusive city. We have inclusive AI and algorithmic justice. We have women in AI ethics, just like yesterday, our keynote speaker of yesterday talking about ethics, AI ethics. And he was able to open, because I joined the conclave yesterday for that presentation, though I was busy with some other things in my office, but I was also listening to him. Eliminating facial recognition bias. We have example, MIT Media Lab studies, and so on. These are inclusive AI and algorithmic justice. Diffusion. Diffusion, quantum, bio, and neurotech. Women are entering next-gen computing fields, breakthrough in neuroengineering and health. Diverse design means better futures. The perspective of women cannot be left out. for breakthroughs in neuroengineering and health, better diverse design, and then the next generation of computing fields, bio and neurotechnology. Redefining engineering, life impact. Engineering is a tool for shaping lives. They are more than machines and software. Human-centered innovation. So we need to redefine engineering in order for it to have life impact. It has to be all-inclusive. Women, men as allies, women encouraging women, cross-generational mentoring and fellowship, and availability of grants will definitely assist and also motivate the role of women in shaping the future of technology. Call to action for institutions. We need to encourage gender parity. We need to create inclusive laboratories and programs. I cannot say it all. Grants must be made available for women startup. I started Smarter Grow in my institution. And before Smarter Grow could start, I can imagine the number of grant applications I've written before I was able to win one, which I started with. And today I got patents for that technology. And since then, every effort to even scale up the technology has not brought forth fruit. I have the technology already patented as a name track. It's on our website, smartergrownigeria.com.ng. We have it there. The name track, to scale it up, I have the patent. It has been a lot of work since 2019 that I started working on it. I've had so many prototypes, smaller, big. Presently, the prototype I'm having now is what we are testing. From one prototype to the other, improving, including more functionalities, and then, we have different prototypes and versions. So there's need to encourage gender parity, create inclusive labs and programs. There must be all-inclusive lab. Listen to and amplify women voices. Amplify women voices. That's for the institutions. Call to action for individuals. Support your peers. As women, support your peers. I was the first academic to attend Edinburgh Laureate Forum in Germany. I was selected in 2000. We were the third HLF, and now they are on the 12th. We were the third HLF. I attended HLF, and getting there, I could see it was ACM that actually brought the advertisement to me, and I applied. Being the first academic in my institution to apply HLF, after myself, about 7 academics have attended HLF. They have been selected. I introduced them, I recommended them, I put them through on how to go about it. I have women that have come into HLF. They have traveled to, it's a program, it's a whole week program. You'll be there, and 200 are always selected every year. And from HLF, I became alumnus of HLF, and then I was inaugurated into Anumload. Anumload gave me the first international grant I had, about 7,000 euro, which I use for the technology I call NIM track, for tracking cattle, tracking them and taking their vital signs. So that was what I used, the Anumload. And 7 of my colleagues have attended HLF from my institution and from other institutions too. Even though some were my PhD students who are now academics, they are already faculty members in other universities after they finish their PhD. We raise awareness and advocate. Raise awareness for your colleagues, women like you from other continents, work together with them. We can achieve greater things. Be intentional about inclusion. Don't just gloss over it. Don't say women are lazy. Bring women close to you. And from there, through HLF, I have friends all around in Sudan, in other African countries, in Kenya, in other African countries with me, South Africa, that we work together. So be intentional about inclusion. These are call to action for individual, for all women. Be intentional about inclusion. Closing thoughts. Closing thoughts. Women engineers are not just participants. They are pioneers. They are pioneers. And in computing, even in my institution here, just like you saw on my introduction or the flyer, I happen to be the pioneer dean of College of Computing. We started this journey 2 years ago, getting accredited for 6 programs in addition to computer science. And so currently we have accreditation for data science, cybersecurity, and we also want encouragement from other institutions. We want partners, data science, cybersecurity. Today, technology made it easy. You don't need to be here physically, but there are ways we can actually, collaborate together to bring forth what should be the results of all these programs in computing. And I personally am an advocate for women in computing. I encourage the women, the ladies that are studying computer science, and I always make them to be bold and to be courageous, even while in class, pushing themselves forward. And any one of them that are really doing well, I encourage them. I involve them in projects. I involve them in what they know how to do. I give them free hand to demonstrate their potentials. These are ways by which they can be encouraged. So currently now we have information and communication technology, we have information technology, all because I was the HOD of computer science, and we got accredited for these 7 programs, which gave back to our College of Computing. And I happen to be the pioneer dean of the college. So we are not just participants, we are actually pioneers. So technology must be inclusive by design. And on my campus, they feel the impact of my technology because the College of Veterinary Medicine, that is where we have the cattle, and that is where I test my technology. They will hang the tracker on the cattle and they can track where their cattle are at every point in time. Let's build the future together. Technology is all we need. This is a closing thought. Women engineers are not just participants, we are pioneers. Thank you for listening. May I entertain questions, comments, and so on? Israt, I'm done.
You are now unmuted.
Thank you. Yes. Can I use my personal example I share with you?
You are now unmuted.
Okay. Thank you very much.
You are now muted.
I finished my bachelor degree as far back as 1996. Then, after my bachelor degree, I served my nation for 1 year. And after serving my nation, that's about 2 years after my bachelor degree, I got married. So you can see that my journey through academia was actually as a married woman. So I started the journey balancing life and work, balancing family life and work. So while I got married, I started my postgraduate program for masters. I had my master's from year 2000 to 2003. I had the master's degree, still giving birth to children. And then while I couldn't get a job, then I settled down because of my husband was in a place I had to leave my job where I was. I moved to the city where he was. I couldn't have a job. So I started the PG program. I finished it. After the PG program, I got a job in academia where I am today as an assistant lecturer. So every effort to do my PhD, and I've always been very, very courageous, and I'm always ambitious to study abroad, outside my country, in computer science. And software engineering has always been in my mind, that I want to be a software engineer. I want to study abroad. I want to know what is happening about all this application they are developing. That has been my thought. And I started with, there's an Indian man that I approached that time, but he was in the industry. I couldn't get along with him to have a university in India. So I started working on China to get a university, and I was working on OWSD. I know some of us will be aware of OWSD. That's Organization for Women Developing World. So I got the scholarship to study in China for 3 years. I have to leave my children back at home, and I left my husband. I was allowed to go to China. The first year, I was there alone. The second year, I was all the while, you can imagine the kind of things I was battling with. While you are also there, you are also taking care of home back in my country, knowing what is going on to the children, the kids, they go to school, my husband will go to work. And then I continue, it wasn't easy. By second year, my kids came to join me in China, and my husband also came. He got a postdoc. So my children came to China, and China for the language class, my children were just attending schools. They couldn't understand anything. Once it is not English, they don't understand. So they were just going there for 1.5 years. They have to sacrifice that for my own career. So they were going to school just to register their presence. Missing out with other children, they play around, they were not understanding anything. So I finished the PhD and I came back home to continue with my career. That was 2012. I spent 3 years in China for my PhD. Graduate Academy of Science, Graduate University, Chinese Academy of Science, Institute of Applied Mathematics. So I got my PhD from Beijing. I came back to Nigeria to come back to my university, and then working, trying. And for the 3 years I spent in China, it was as if I would not be able to finish. I said, I have 3 years because I was on study leave. I have to go back to my university. So working day and night, working day back to back to ensure that I finish my research work, I publish papers as required by the institute, and I graduated. And coming back to my institution, my going to China was an eye-opener. It was the breakthrough and the beginning of my career, so to say. Though I've published papers before going to China, but going to China to study for my PhD was the beginning of my career. So I was open to so many areas, theoretical area, research area. So I started with it, and I was doing them, publishing papers. And you can check me on Scopus, check me on Web of Science, and you see the publication and where I'm actually publishing now with my PhD student, master student. I have some of them working with me. And it wasn't easy. Working, I'll keep my children after school, we keep them in the daycare, because by 5:30, I'm just going back home from the university. I will go to school to pick them, and it wasn't very easy, but you just have to go through it until I got to the zenith of the career, which is becoming a professor. Now I have many graduate students I'm supervising. They have paper to publish, putting them through, making contribution, writing grant proposals, winning grants. And if you check also my profile too, you see there, winning grants and getting 1 or 2 things to do and all of that. That has been the journey. Not very easy. It has been with determination, motivation, and support for my family. My family supported me. My children, they cooperated. My husband also cooperated. They supported me. It wasn't easy. At times, you work all through the night till daybreak, trying to submit paper, putting in reviewers' comments, trying to meet up with deadlines, and even holding administrative posts, even getting our college approved. We are my department as computer science alone has been on New York getting College of Computing for how many years? For more than 15 years. This is my 20th year in this university where I'm working now. I spent 20 years here. September 27 will make it 20 years that I entered into the university as an assistant lecturer. But, you know, we have to, the opportunity came Writing curricula for all this program wasn't easy, but going through the hurdles and everything, today we have College of Computing, allowing youths and young hearts, young minds to express their potential in different areas of computing, not just computer science. Some are good at writing codes, some in data science, cyber security, and all of that. So that has been the journey, not so easy, but here I am today, and I believe all women can make it. And that is why I encourage women, and that is why I have this ACFW, we have program as advocates for women to pick up career in computing. I hope I've been able to answer your question, Elisa.
You are now unmuted.
Okay, activities. Is it in academia or as ACMW? Yes, as ACFW, I think
You are now muted.
it is our duty to be intentional about including girls in in career talk, doing career talk for them, organizing programs, letting them know the areas that women can actually fit in very well, where they can demonstrate their potentials. There are areas that women can fit in very well. What's your program? Okay. Women can fit in very well. So we do advocacy program. The advocacy program is to encourage them, motivate them, and talk them into career, into computing as a career. We can also have activities bringing together women to have maybe incubator center where women, girls, primary and secondary school can come to, or we can have incubator center in a community for women to demonstrate their potentials in computing. Incubator center, like, they come after they go through, some girls, the children of nowadays, the Gen Z, when they sit down with computer and you're giving them a particular program, before you know it, they know more than you. So if there is an incubator center, maybe in a community, primary school, other primary school representative can come after class. If it's going to be 2 hours every day, they sit down by the computer, they learn, and they go back home. This will create their interest from primary school in going into STEM, science, technology, engineering, and mathematics. These are part of the activities that can really help us.
You are now unmuted.
Yeah. Yeah. Thank you. Thank you. Yeah. Yeah. I look forward to that. Thank you. Yeah.
OT Arugandade, and of course to all of the audience for tuning in and participating. We will be back tomorrow with another set of thought provoking sessions. Stay tuned. YouTube live links will be shared 1 hour before each session.
You are now muted.